So here are the, we're going to do this test in 3 sections. This is the first 20 questions. Here we go. The man that developed a calculus equation generating variables known as quantum numbers, that was the guy that had the cat. Quantum numbers came from Schrodinger, so that one would have been C. The man that noticed that light emitted from neon other lights consisted of specific wavelengths that correspond to specific energies, and then developed the concept of energy levels. That was this model of the atom, you know, the Niels Bohr model, where you have the rings around the nucleus. We did the spectrum, the tubes, light tubes in the glasses, and looked at the colored lines that were emitted. That was Niels Bohr. Around 1800, the matter was made of atoms. That was Dalton. He was John Dalton. He was an English school teacher who took the work of other people and kind of took a theory from Gay-Lussac and the work of Lavoisier. And anyway, he used the work of other people, Proust, and developed the atomic theory. He was pretty much right, except that he said they were all identical, and now we know about isotopes, which are they're different. Isotopes are different because they have different neutrons, but Dalton, other than that, was correct. The discovery of electrons, I showed you a little video on a cathode ray tube with little green lines, and the green line bent when you put a magnet near it, and that was Thomson. And if you change where it is, or if you see an electron, you change where it's going because electrons are so lightweight. So when you see it, light bounces off of it, and that changes it. That's the Heisenberg uncertainty principle. All right, since when we see an electron, we change where it is, we can't describe an atom by looking at it. Consequently, we describe an atom by treating it as a wave. If you treat it as a wave, you can mathematically calculate regions in space where the electrons would be, and those are the orbitals that we talked about. All right, I'll let you refer to a periodic table for this one. But if you look at the periodic table, you'll see that nitrogen has 7 protons. On your periodic table, if you look at it, there'll be an N in the box, and the 7 will be up here. In proper nuclear notation, the 7 goes on the bottom. So the periodic table can put the atomic number wherever they want to. But in nuclear convention like this, the 7 always goes down, or the atomic number always goes here, and the mass goes up here. And so this is nitrogen 14. Since its atomic number is 7, it has 7 protons. And then protons plus the neutrons equals the mass. So if it's 14 and there's 7 protons, then there must also be 7 neutrons. Oops, that was C. The atomic mass of nitrogen 14, well, that's the mass number, so that is E. And 2 atoms of the same element that have different numbers of neutrons, those are the isotopes that Dalton didn't know about. So isotopes are what Dalton didn't realize, but they exist because of the different numbers of neutrons. The actual mass numbers that you see on your periodic table, like if you look at nitrogen, it'll be 14 point something down here. 14 point, I think it's 0.01. That means that there's more than just one kind of isotope for nitrogen, but most of the nitrogen is nitrogen 14 because the average is closest to 14. All right, so 2 atoms of the same element, that would be B. All right, so there's your first 10. Now let's go to the next 10. Okay, so if you look at phosphorus on your periodic table, you'll see that phosphorus has 15 protons. If it has a -3 charge, that means that it's gained electrons. Well, normally the electrons equal the protons if there's no charge. But if there's a negative 3 charge, that means you've gained 3. So that would be 18. Oh, the answer is C. No, the answer is E. Sorry. All right. How many electrons would nitrogen need to gain in order to have 8 electrons in its outer shell? Now here's nitrogen. It's got 7 electrons. The electron configuration is 1s2, 2s2, 2p3. So 2, 4, 7. In the outer shell, there are 5 electrons, 2 plus 3. So how many does it need to gain in order to have 8? The reason I ask that question is I'm trying to lay groundwork for what comes later in the course. The atoms that have 4 or less electrons will lose electrons that go down to 0 when they have chemical reactions. Those with 5 or more will gain electrons and get to 8 when they react with other things. So one atom might lose 3 electrons, like if you had aluminum with 3 electrons in its outer shell and nitrogen with 5 in its outer shell, aluminum would lose 3 and nitrogen would gain 3, and so that the ratio between them would be 1 to 1. But if you had something like sodium combining with nitrogen, sodium only has 1 electron in its outer shell, and the nitrogen again would gain 3. So you'd have to have 3 atoms of sodium to provide enough electrons to satisfy nitrogen's need to gain 3. So the formula would be Na3N. That's the background of chemical formulas. It'd be written like this. And this 3 here applies to the sodium. All right, so which one is equal to the number of electrons in a neutral atom? And the number of electrons in a neutral atom would be the protons. That's A. All right, that phone call that you heard was my wife, so I need to stop and take that. I'll be right back with you.